Okay, so to continue on with this example 2, I probably should have split it up into the 2 videos. Apologies for that. So at the moment we're looking at examples where we apply all that we know, all the calculations, to give some evidence about what we know and claims that are made. So we had this confidence interval for mean, for our population mean of body temperatures, so it's between 36.7 and 36.9. So they want us to say, on the basis of the confidence interval, explain whether or not the 92 data are consistent with the 1861 value of 37 degrees. So the way I would answer this is I'd start by stating what I'd say the significant end of the confidence interval is. So from confidence interval in A, we see that mu, so that's the population mean of body temperatures, is less than or equal to 36.9 degrees Celsius. So then we're going to relate it back to the question. Hence we are 95% confident that it cannot be equal to 37 degrees Celsius. And so hence the 1992 data is not consistent with the 1861 value of mu equal to 37.0 degrees. So what we're doing is we're stating the significant end, then we're going to relate it back to the question. So I suppose here, instead of saying we are 95% confident that it cannot be equal to 37 degrees, you could also say that the 95% confidence interval does not include 37. Really, that's saying the same thing. And so then we conclude, hence the 92 data is not consistent with this value. Yep, okay. So then one final question. A statistician claims that based on the 92 study, we can be 95% confident that no more than 1.4% of healthy people will have a body temperature above 38 degrees Celsius. So given that mu is again going to be 0.5, so what I'm going to do is I'm going to start by saying assume that our population mean of body temperatures is 36.7 degrees Celsius. So hence we want to know the probability of so here we're working with our population distribution. Just need to be very clear about this. We're not working with the distribution of the sample means, we're actually working with our population distribution. So when we want to know the probability of x being greater than 38, so that's going to be equal to NCD. So this is using our NCD function. If we use our NCD function, our value is 38, and our standard deviation, or for the moment I've just forgotten exactly what you need to enter, so just let me go back and find out. So menu 2, exit, quit all that, so we go to distribution, normal, NCD, so we need to enter the lower, so the lower is 38 and the upper is 1 e to the 99, so 1 times 10 to the power of 99, and then our standard deviation is 0.5, and our mean is, we're assuming that to be 36.7, so that is equal to, or actually I'm sorry, I might just go across this on the same line here. So this is our data for our population distribution. So we're assuming the mean to be 36.7. We know we've got a standard distribution of 0.5. And so then that's going to be equal to, if we plug in the values, so the lower was 38, upper was 1 times 10 to the power of 99, sigma was 0.5, whoops, and mu was, we're assuming to be 36.7, and so we get 4.66 times 10 to the power of 3, so that's 0.00466, so that's the 3 significant figures. Okay, so that's when we assume mu to be equal to 36.7. Now if we assume mu to be equal to 36.9, you can probably see where this is going, and hence probability that x is greater than 38. Again, it's an NCD kind of thing, so 38 is the lower, 1e to the 99 is the upper, 0.5 is our standard deviation, 36.9 is our mean that we're taking, and so that's going to be equal, if I go to my calculator again, all I have to do is actually just change this to 36.9, that gives me 0.0139, or 1.39%, which is looking vaguely like the 1.4% we were asked about. So what I'm going to say is we are 95% confident that the mean of the population lies between 36.7 and 36.9. As for this range of values, the probability of so as for this range of values, the probability of healthy, spelling's atrocious at the moment, so values of the probability of a healthy person having a temperature of 38 degrees Celsius. Apologies, just while I get the formatting correct. Okay, so as for this range of values, the probability of a healthy person having a temperature of 38 degrees or more, I really should say of more than 38, because that's what the question says, is at most 1.39%. We can support the claim given above. So we're 95% confident that the mean of the population lies between those two. As your mean increases, goes from 36.7 to 36.9, it's getting closer to 38, and so it's including more of the area in the distribution is going to be greater than 38, because the distribution is moving across, so we're getting more area greater than 38. So at most we get 1.39%. So we can be 95% confident that no more than 1.4% of healthy people will have a body temperature above 38. So that's the way I do that question. I guess in one way you could argue, do we really need to do the lower value? I think it's good to do that for completeness, because it gives you your two bounding values and enables you to conclude. Okay, so that's the end of the examples. So as the sheet will tell you, I want you to be doing questions 7 I.3 and I.4, questions 1 to 3 and 1 and 2 respectively from those. Okay, thanks.